Thank you all for joining us for today's webinar. First, let me introduce myself. My name is Sujana. I'm from Dhanush Engineering Services India Private Limited. I will be responsible for hosting this webinar today. Today, we are presenting a webinar on MEP Design for Architect. Will be presented by 5 eminent speakers, and I'm glad to welcome Mr. Chakradhar, Mr. Satyanath Mukti, Mr. Madan, Mr. Karthikeyan, and Mr. Srinivas. So now our first speaker and our director, Mr. Chakradhar, will speak about our organization and webinar for a few minutes.
Good morning, all. A warm welcome to all, and we thank you for being here on a Saturday. And we really appreciate your interest in knowing about the content which we are going to talk about. A brief about myself. I am Chakradhar Majety and the founder of Dhanush Engineering Services India Private Limited. I will be giving you just maybe 3 to 4 minutes of base introduction about our organization and about the webinar. So we started our organization in 2004, and it's almost 18 years now into this training and skill development. We are the first and only NSDC training partner, which is approved by NSDC in MEP sector. So we are very proud of being so. We are also proud to be member of IISc, India International Skill Center, which facilitates the engineers, the technicians who wants to go abroad. We facilitate, we guide them how we should go there, how you can get upskilled. And there are only 96 companies who have this particular status of IISc, India International Skill Center. And all these approvals how we got from NSDC, and NSDC, which is working under the Ministry of Skill Development and Entrepreneurship. Our first e-learning module got launched in 2009. So we were way ahead of the industry, where now today everybody is talking about digital world, digital mode of training. So we are happy to share that we were digitally available from 2009, and we are also doing it now. So we have a dedicated placement cell which supports the employers and the candidates who are looking for job. The candidate may be our student or can be an outsider who have done no program with us. Both the our base responsibility we feel is to connect the employer who is in need of good manpower and the manpower or the skilled engineers and technicians who are looking for job, to connect them to the industry. So you can also see our job openings in the below link which we have been shown over there. We have a track record of training around 25,000 engineers and technicians till now from the inception. So we are very happy to be there. And my vision is to go do it for 1 million people. We have very efficient and experienced faculties within our company, and they all have MEP industrial exposure. So corporate trainings, this is another feather in our cap. We are very happy to say that we have been doing corporate training for ISRO, Tata Housing, ETA, Blue Star, and L&T, Deloitte, and many other companies. We are authorized training partners of Blue Star, where we train their technicians across Andhra and Telangana. So this is about our organization. Now I move on to the webinar. Why this webinar has been initiated? We felt that there is a lot of discussion which happens in the project with architect and the HVAC consultant, electrical consultant, and the plumbing consultant. These three consultants has to really fight out with the architects to get what is to be done as per the standards and the codes. So we here trying to ease out an effort from our side to ease out this particular discussion by giving information to the architects. I can see there in the audience we have owners of the business, we see senior architects, we also see the students from the architecture colleges. So I think this is a wonderful platform for us to discuss about, what are the priorities, what are the things which MEP professional has to implement, and it can only be happen with the support of the architect, because architect is the ultimate decision maker with respect to many of the parameters which our eminent speakers will be speaking now. Okay, I thank you for once again, I thank you all for being over here, and I move on to the next speaker. Yeah.
So thank you, Mr. Chakradhar, for providing the information about the company and the webinar. Now, before starting the webinar, make sure that we have a chat box to source your questions and to make sure we are helping you as best as we can on this webinar. Feel free to drop questions on the topics and share your experiences. We will answer your questions by the end of each guest session. So now we are starting the webinar with our first speaker, Mr. Satyanath Mukti. Off chesara, sir.
No, it's okay.
So now we are starting the webinar with first speaker, Mr. Karthikeyan. Now here is our special guest, Mr. Karthikeyan. Mr. Karthikeyan, please share your screen and start webinar.
Okay. Mr. Karthikeyan is Chief Electrical Engineer in L&T, and he has more than 20 years of experience. He's a graduate in electrical engineering, and he's also having a MBA in personal management. So this is a brief introduction about him, and we take it forward here from here. Mr. Karthikeyan, he's also there. Yeah, Karthikeyan, please take it over. Thank you.
Yeah, thank you. Chakradhar, can you just enable the screen to share my presentation?
Yeah, it has been enabled, Karthikeyan.
Just a second. Is my screen visible to all?
Visible. It is visible. Yeah, full screen. And, yes, great.
Yeah, and is my voice audible? Clear?
Clear. Clear.
Yeah, thanks. Hi, welcome you all on a lovely Saturday morning, and thanks for attending on a weekend. See, today's session, as Mr. Chakradhar told, he has set the theme that it's a mix of crowd where we have experienced architects, owners of the architects firm, and we have some students or some of them who have just started the career. This session is not about me teaching or something showing what we are doing. It's just going to be a sharing of information and the processes what we follow in our organization, which will be and helpful to all of you people. And in the chat box, you can just leave your questions, and that would be more interesting to discuss at the end of each session. And as the topic, today's topic is about MEP design for architects. So we need to start the role and responsibility of the architects in the construction, especially for the buildings. As you all know, the architects are generally called as captain of the ship or pilot of the aircraft. See, they are the one who plays a major role, especially in a building where they need to ensure that the building is designed and to ensure that it meets all the functional requirements for the application it is intended, following all the building codes and regulations, and also to ensure that the aesthetical appearance are taken care. At the same time, the building has to be very, very important to take care of the structural elements. And of course, all the MEP services which has to facilitate in the building, it has to be taken care. So in addition to that, it has to meet, now all the buildings are come with the green building requirements, where it has to compliance to the USGBC, IGBC, Graham, compliance to ECBC norms. So architects play a very vast role, and they have to ensure that they take along all the people together and ensure that a coordinated, a functional building is handed over to the end customer where he makes the profit out of it. So with this role and responsibility, we will get into the today's session. See, MEP services, you all know about what are all the MEP services are getting into any type of the building. But just to touch upon, there are a lot of new systems which are coming up in lot of buildings and projects. What we are doing as on date. See, piping system, LPG and CNG gas piping, fuel piping. Fuel piping is predominantly used in all airport jobs. So since we are doing a lot of medical care projects, there are hospitals. So medical gas piping is also one of the systems which is getting involved. Because when I started my career, that these kind of systems were not in place. Actually, now all the systems slowly, one by one, it is all getting into the building. And especially on the extra low voltage system, where we have a specialized system called ICT, Information and Communication Technology. There are a lot of systems are coming into picture. So these are the things which were other than the usual traditional HVAC, electrical piping, and fire detection alarm. Now, on the coordination level, if we just compare the percentage of coordination level involved in any kind of building, 35 to 40% from our experience, we can say the architects play a major role, followed by the structure and then the MEP put together. So in this itself, you can make out the amount of coordination what the architects are coordinating with all the interdisciplinary discipline plays a major role. Now, why the importance of coordination is required? See, you have in a building, the ultimate aim of all, though it's same, but then the perspective and the priority varies from an architect, from a structural engineer, from an MEP perspective. You have a difference in perspective. When you discuss on a workshop for a building to freeze all the requirements, the architect will say that he will ensure that the prime place is not given to the MEP person to adhere to the requirements. And at the same time, if you see the structural engineers, they will say that these are all the minimum requirement with respect to the beam depths and the slab thickness. And they will say that wherever the MEP goes and asks the cutouts for taking the services, he will say that you cannot take it here because it's going to weaken the structure system. So there is always a difference of the perspective in the building itself. And MEP perspective, you see, we have a set of statutory requirements has to be met. And at the same time, the MEP has to ensure that the constructability and maintainability is taken care. If I keep an equipment, I need to ensure that the equipment is in a position to maintain at a later point of time on our usual maintenance. So this is something which the MEP people will look into the aspect on the energy conservation, on the maintainability, constructability. So there's a difference in opinion, but ultimately all of them are working on a single project of handing over a building to the end customer. And end customer always comes, they say that give me the maximum sellable area or a rentable area, because for him, every square feet is money. So ultimately, the MEP guys has to really struggle in any of the discussions, design discussions. For each and every space in a building, we need to convince the client and as well as the architects, and we need to establish and give the evidence that why I want this much space. So what are all the effects of improper interface and coordination? See, when you don't have when you don't do a proper interface and coordination, it leads to a lot of rework, and it leads to a lot of clashes between the services. So, and it needs a lot of improper construction. At the end of the day, it will have a over cost run due to the reworker side. So the best way is to outcome of the effective coordination is to respect each and every discipline's requirement and see that an engineer at the same time architect be reasonable on understanding the dynamics of each requirement, so that the MEP person is also not asking more space, and at the same time the architects also should not give a less space which is going to compromise on the maintenance and constructability. So it's an integrated works, so that a best outcome is the best way to move forward on the coordination to hand over a good project. Now, just to touch upon on the electrical systems, these are all the systems in place. So to start with this, the distribution of electrical power starts from the switchyard or the substation, where we have to receive the power from the utility company, from where the power is stepped down using the transformers, and then through the MB and LT switchboard, it is further distributed inside the building with the help of rising mains, bus ducts, cables, wires, through the final taking up to the final load. And then we have the lighting is a very one of the system where we have extensively we coordinate with the architect. Now it's just lighting is not just a simple lighting. We have a specialist lighting, we have an architectural lighting, aesthetic lighting, landscape lighting, facade lighting. There are a lot of lightings come into picture when you go for a large project. And then, of course, with respect to the safety, we need to take care of earthing and lighting production system. So in each and every aspect of whatever the system which I'm talking about here, I need to coordinate with all the architects and the structural engineer along with the other MEP discipline. Then only we can get a quality product output. So codes and standards, I just want to touch because for each and every discipline, you need to follow a set of codes and standards. And for especially for electrical, it's more stringent because it deals with the safety of the people and as well as the safety of the equipment. And at the same time, I need to deliver the power with proper regulated power so that all the equipments can work in a proper way. So these are all the building codes and standards which we follow in any of the project. So which has to be strictly followed by any practicing design engineer in any of the buildings. And as I said that a good electrical design is to ensure that the operational a person who is operating the equipment, he should feel safe so that the equipments can be handled properly. And at the same time, when I design a system, I need to ensure the basic three parameters of the electricals are the voltage, current, and frequency. It has to be regulated and it has to be delivered to the equipment so that it doesn't malfunction. And at the same time, at any point of time, the equipment also has to be protected, and only the faulty equipments has to be discriminated or segregated from the healthy systems. So these are all the primary responsibility of the electrical design engineer to deliver. This is a very, very basic distribution in a very simplest form we would like to explain. So this is where the power, just a second. Yeah. This is where the power from the utility company is brought into the EB substation. The EB substation, as I said, it depends on the demand. I will be covering in the subsequent slides. So when you get the power here, this is where it decided whether the power which I'm getting, whether it is a low voltage or an extra high voltage or a high voltage. It depends on the size of the building and the demand. And then from here, it gets safely into the metering with the HD panel. And then it goes to the consumer HD panel where it's getting metered. Then from here, it is getting into the transformer, and transformer is a very, very, very important equipment in the electrical distribution where it steps down the voltage to the user level of the equipment inside the building, where from through the main LT panel, I just distribute further inside the building. So each and everything we will be covering how we are going to manage in the entire process. So as I said, the first and most important step is to do the electrical load estimation to ascertain what is the voltage level it falls under this category. So when you do the electrical load estimation, I need to coordinate with my other MEP discipline departments where I need to get the load from my HVAC discipline. Then I need to get the load from the plumbing design engineers. Then I need to get the load from the firefighting engineers. And at the same time, I need to get all the load requirements from my extra low voltage system. So collide all these things with all the diversity factors based on the application of the building, we finally get a load called the maximum demand. The maximum demand are in terms of in megawatt or kilowatt. So based on that, we need to see what is the voltage level we need to get the power supply to the building from the electricity company. That is the basic and the most important step. See, this is an extract from the Tamil Nadu state electricity regulation. You can see here, when the voltage is in the range of 240 volts or 415 volts, it comes under the category of low tension category. When the voltage comes under the category of 11 kV and up to 33 kV, it comes under the category of high tension supply. And the moment it goes beyond 66 kV and above, it comes under the extra high voltage tension. This is very, very important because this is the one will decide what is the size of the switchyard and the substation we have to plan and what is the size required and at what location it is required. And on the right side, if you see on the screen, we have the category of supply. When I say that when the supply is under the low tension supply category, the load which is up to the 4 kilowatt, it comes under the category of low voltage. Generally, if you see in our residential application for flats, we get a three-phase supply. It comes under 415 volts. Okay, and when the demand goes in the range of 112 kilowatt, then up to the 112 kilowatt, it comes under the three-phase supply 415 volts. When the demand goes between 112 kilowatt from 63 kVA to 112 kilowatt, it comes under the category. Maybe up to 5 MVA, it comes under the category of 11 kilovolts. And then the moment it goes beyond 5 MVA, it comes under the category of 33 kV. So this is the first and most important. The electrical engineer has to decide based on the load estimation, arrive what is the voltage level he is going to bring in. And then moment he brings in, then this is another extract of Tamil Nadu's CIG regulation guidelines. This is just, I just want to flash here, just to make you to understand. It clearly says what is the clearances I need to make when I go for the, what is the rear clearance I need to make when I plan an electrical room substation, and what is the site clearance I need to make. And when I go for when I plan for a cable cellar or cable trench, what is the clearances I need to make, and what is the depth I should go. You can see here there is a meaning in all the dimensions what they're given here. See, 75 centimeter is nothing but 750 mm. Okay, where I need to put a cable tray based on the requirement. This is a multi-level. This is a 4-tier cable tray arrangement. And you might be seeing why this space is left out. This is also minimum BLR 750 mm. This is, since there are multi-tier cable trays are coming, a person has to get down and has to access this cable, which is at the lowermost tray. So, and these dimensions, what they're giving 30 mm, which is the 30 centimeter, which is nothing but 300 mm for the person at the time of execution, at the time of maintenance. Someone has to put their hand and do the maintenance. So each and every dimension, what has been projected, what has been shown here, is to ensure that it can be executed and it can be maintained. Same way, there is a typical arrangement of how the cable can be taken in an excavated trench, and this is the typical arrangement of an earth electrode, how it has to be installed with all the dimensions. See, this is just only to give you an idea that each and every state has a guidelines where I request all the architects also to go through. You don't need to understand the technicalities of all those things, but these are all very common sense to understand why they are asking. If you see here, on the rear clearance of the panel, they want minimum 150 mm. This is required because when there is a maintenance, because I have a cable termination on the rear side of the panel, a person has to go behind the panel and do some maintenance at a later date, or at the time of execution, he needs to stand and do the work. So this is the minimum requirement, and we need to understand, because some of the architects, I see that why can't we keep the panel flush to the wall? Because the design of the panel is in such a way that I need the rear clearance and person has to go backside. And at the same time, side clearance of the panel is, when a person is working on the backside of the panel, if there is any fire or electrical fault is happening, he need to run out of the room, and you need to have a site clearance so that safely he can come out. You cannot give a 300 mm gap where a person has to squeeze in and come out, because he will get stuck when doing any hazardous situation. And this is an extract from the Central Power Irrigation Board of a typical 33 kV air insulated switchyard. See, everything is given here. This is the plan, what you're seeing here, and this is the section, elevation, and all the arrangement, everything is given. See the dimensions, everything is given. Though you cannot read here, but just to give you an idea that each and everything, even the electrical engineer will refer to these guidelines and will come to the architects when you people do the master planning and say that, look, I have a requirement of switchyard of 33 kV, this is the requirement. So you also can look into this regulation to understand why the electrical engineer is asking, and then have a good discussion so that you can narrow down on a solution so that both of you are happy at the end of the day, and at the same time it meets the statutory requirements too. See, these are all the very, very, very basic thing in substation electrical room. This is applicable not only for electrical, even for all MEP disciplines, you can say. See, generally, from the electrical engineer's perspective, as the scope starts from the electrical substation, the major coordination starts there and then gets into the building detailing, where inside the building, once I bring the supply, I have every floor, I will be having a typical electrical room. I will have the electrical shaft. Then I have the electrical BB cupboard to keep my final MCB boards and switch boards, everything I need to coordinate. And finally, the external site plan, where the electrical engineer has to bring the cable from the substation through the excavated trench or a tunnel, whatever it is, and then he has to get inside the building. These are the three predominant areas where the electrical engineer has to coordinate in any building. And at the same time, the basic and important thing for an electrical engineer to see that any substation, if it is an indoor substation, it has to be well ventilated, and at the same time, it has to be easily accessible. See, any maintenance which I have to bring out of the substation or electrical room, I need to have the accessibility. You cannot give me a place just below the staircase in one corner with 2 columns in front of the panels. It's not possible for the person to bring in or take out the equipment for a maintenance. This is where in most of the project happens, but then we as an engineer has to convince and ensure that we get a proper space so that the operation is taken care. So preferably in a separate building above flood level, because this flood level, why I'm touching on this, there was an incident in Chennai in 2015 where the complete city got flooded, and whatever substation which we planned inside below the basement, inside the basement, and at the ground level where the flood levels are not considered at the time of designing, all the equipments got flooded and the complete building was into the standstill, and we could not able to power up the building. Even the waters are taken out of the building. So that was a very tough time. And then after that, there was a regulation they have passed on that any equipment which is to be located has to be above the flood level, or from the ground level, you need to elevate it at minimum 900 mm. This is a rule they have implemented. So in Chennai or in Tamil Nadu, we cannot keep any substation in the basement. So, but in some other states, they are still allowing, but then it has to be checked before we get into the design. So avoid in basement to accommodate DG, because DG and a transformer, if you're keeping it in the basement, I need to bring the fresh air, either because the moment it goes into the basement, I need to go for a forced ventilation. Then space for future expansion. All these are the basic things which has to be taken care of. See, this is all the guidelines which we follow internally in our organization, where in this table you can easily make out, if I have to go for a meeting room, what is the minimum space of the room required, and where is the preference, where I want it. And this 15 meters from the site entrance is a norm, because a person from the electricity board, when he comes for the maintenance or under the time of getting the noting of the metering requirement consumption, it has to be within 15 meters. You have to follow this. But generally what happened in the entrance, which is a prime area, the architect will not allow to give us a meeting room because he said that my aesthetics will be affected. So this is something which they need to compromise. But there are now a lot of ideas we're bringing in where you may not realize that it is a meeting room. So that is how they are just making it more aesthetically appealing, so that it's a win-win situation for both the architects and as well as for the electrical engineer. So if you can see, I'm just not going depth into these things. This is just to give you an idea. In substation, if you see, when I have an HT panel of 3-panel board, this is the dimension is required and where it is located. Same way, when I keep 2 transformers next to each other, and each transformer's dimension is, this is the space is required. Like that for the main LT panel room, DG set room, and these are all the ratings. These are the ratings of the HT panel per panel. So based on the number of panels, you have to decide what is the dimension. Suppose in case I have 3 panels, then I need to go for the length of the panel 3 meters, which is falling under the category of 11 kV. If it is a 33 kVk panel, then I need to go for the panel of 1.5 meters each panel. If it is 3 panel, it is going to be 4.5 meters. So you can see, the more the voltage, higher the dimension of the panel. And at the same time, as I said, when you have an HT panel, these are the clearances you need to take care: front clearance, rear clearance, side clearance, top clearance. All these things has to be maintained. The top clearance is one where I need to take the cable. I need to have a bending radius to be maintained so that it is easily terminated into the panel. So these are all minimum requirement which has to be followed in any of the execution. And these are all the typical transformer ratings, the dimensions, and what are all the requirements you need to follow, the clearances which you need to follow for the maintenance and operations. This is again for the DG, so which will give you a fair idea what is the clearance and what is the dimension I need to maintain. This weight is the requirement for the structural engineers, which we will give them. This is the dynamic load for them to design the foundation. And this is an extract from one of our airport job where we have, this is the plan of the DG room. These are the trench, the hatch portion, what you're seeing, these are the trench for the cable entry. And these are the clearances which we had given. You can see, I have to locate the DG in between the beams so that the crossings, and at the same time, I need to, because the structural engineer will not allow to keep the equipment on the beam. And at the same time, I cannot take any cutout or any sleeves in the beam. So I need to plan. This is something which we need to plan, and according to the structural engineer, will locate the beams and the columns in place. And in between, you see there are no columns are planned. So this is how we need to coordinate and understand each other requirement so that everybody's requirement is taken care. And this is the sectional view of the DG. Why I have asking that much height? What is the reason and what are the equipments which is coming, so that the height is convinced to all of these people. And this is the transformer on a plan with all the dimensions. After doing all those things, these are all the executed photos. You can see why we are asking this much space required, and this is the outcome of the sub switchyard after executed. And this is the GAS switchyard outdoor application. And these are all the power transformers based on the voltage level. You can see. This is a 132 kV transformer. These are called the power transformer, and these are the distribution transformers, the 3/11 kV. So you can see the size, and the requirements also varies between the power transformer and the distribution transformer. So these are all the HT switchboards, how it is located, and you can see the clearances. Why we are asking on the rear, side, front. You can see these are the tri-type transformers located inside the building with the foundation details. This is the trench, and why we are asking the clearances, because to take out. And you can see how nicely it is coordinated with the lighting, the cable trays, and the ventilation, so that none of the you can see the light fixtures are coordinated exactly in front of the transformer, not on top of the transformer, because this is where I need the illumination for the operation and maintenance guys to look into this. And at the same time, the ventilation, they have what we are coordinated here, because it has to be in front of the equipment, not on top of the equipment. And the cable tray is exactly coordinated and kept on top of the transformer, so that it is feeding the transformer and as well as the output of the transformer. This is the outdoor transformer where it is located. These are all the generator room. This is an indoor generator room without the acoustic enclosure. You can see how it is coordinated. And at the same time, these are the generators with the acoustic proof enclosure. So this is the exhaust pipes. And this also, we have a regulation with the central port pollution control board, where the height restrictions, and I need to see what is a nearby building. At the same time, I need to check with the architect with respect to the height. So all these things, everywhere you see, everybody is coordinating and involved. This is the HSD yard, underground diesel storage yard. So this also, I need to have a proper clearance for the truck to unload and move out. And these are all the previous, till the previous stage, what we have seen, it's all from on the external side. Now we are getting into the inside of the building. The inside of the building, main building, where we see, you will start with an electrical room, you have a control room, you have a UPS room, you have a HVAC panel room, you have an AHE room. So there are a lot of rooms where I need to get my power into the building for each and every equipment. So these are all the typical sizes of the rooms what we give, and what is the preferred location also we have explained here. And to take, when I have an high-rise building, I need to take the power from the lowermost building to the topmost terrace. So I need to have coordinate a cutout and shafts for taking the thing for the cable trays and as well as the rising main, and what is and in which location I need, and at the same time where the lighting production cutouts are required in the building very, and at the same time where my cutout for cables in AH room I have to plan, what is the space for the HSD, all these things you see, we give this requirement and where it is required, and I need to have an extensive coordination with the architects and structural engineer. Yeah, and this is the checklist which in our organization we follow. This is just to only to give an idea for each and every area. See the level of interdisciplinary coordination between the architect, structural, HVAC, fire, piping, and PH engineers. You see, switchyard, I need to have a collaboration with architect, structural, and FPC. This is the fire production also. As I told, the power transformer, I need to go for a fire production based on either water or gas. So I need to coordinate with these three people to ensure that my switchyard is compliant to the statutory code, and at the same time, it is not. It is appealing to the architecture that I am not spoiling his elevation. At the same time, see the HT panel room with the 4 people I need to coordinate. Same way for the transformer DG. You can see for the even for the lift passenger, I need to coordinate with the architect to see the shafts are located and it meets the requirement. And at the same time, with the structural people, I need to see where I need to give the headroom. and with the HVAC engineer, how to get the ventilation properly done. So like this, each and every area, there is a checklist, and I need to coordinate with minimum people. And you can see for the rising main, UPS room, electrical room, lighting. Lighting is one area where all the architects will be very enthusiastically participate, because that is more of an aesthetic point from their point of view. And from the electrical engineer, I need to ensure the lighting design which I make, it takes care of the illumination. So these are all the checklists. Just to give you an idea, what is the process we adopt to have a proper coordination. And this is the flowchart we follow for the false ceiling coordination in our organization. You see, everybody is involved. See, the moment when the architectural structural plans for false ceiling is given to the MEP people, the MEP people will work out, and then they circulate the RCP to the MEP engineers. We will just first have a cursory check, and then once that is done, we will have a workshop with respect to the location of the MEP fixtures and routing. So once we are all agreed, then it goes to the next finalization of the routes and elevation. If there is a difference in opinion, we'll again go back. We will tell the architect or the structural people. Sometimes the beam depths also, they will not compromise. We will say, no, we need to reduce the beam depth so that the light fixtures, for example, if there is a light fixture exactly coming below the beam depth, I need a minimum of 50 to 60 mm clearance to mount my light fixture. So this process continues in the workshop, and then moment everybody is in agreement, then it comes to the finalization of routing and elevations. And once that is done, the hard copy and the markings goes to the BIM modelers, and then finally it is getting modeled. Finally, it is checked for the clash free. And once the clash free is done, it's getting into the architect and final sign off. And once it is done, it is given to the site. This is the process we follow for the false ceiling coordination. Like this, we have each and every coordination. See, this is in the process in our organization, we follow the process of either on a hand sketch or on AutoCAD, where we will tell them to draw the scheme, single line scheme. We call it as a single line scheme. You can see the different colors has been used by different disciplines, so that we ensure, see, this is the ELV cable tray. So if that guy is coming here, I need to ensure that the electrical cable tray is not coming along with that. So I need to plan where I am not, and the electrical cable tray is planned here. At the same time, you can see the sprinkler pipe is here. So there is always a space is defined and agreed between among MEP engineers in the scheme level itself, so that when you go to the detailed design and the GFC coordination, you don't have a clash and redoing everything. Because for a small area, it's fine. For a vast area where we have 1 lakh, 1.5 square feet per floor, if you do a small mistake in the scheme, you are going to spend a hell lot of time in redoing everything. Not only your time, even the drafting time. So it's a money which you have to, the time and money. So this is another extract of the single line, what we follow in our organization. And then once that is done, then we get into the rooms where we, on a 2D drawing, we just plan locating the panels with the clearances. You can see here, this is the front side of the front side panel. When I keep the panels facing each other, I need to follow the minimum clearance when it's facing each other. And these are the cutouts and shafts which I got for me to take the rising main and the cable trays. So all these things are well coordinated with the dimensions clearly specified, and I need to demonstrate why I want this much space with all this dimension, and then only everybody accepts. And once this is done, it is given to the to the 3D modeler, and then you can see the 3D extract of this, where it is nicely coordinated, and ensure that we have the proper clear. This is an extract of the 3D model. Same way, see the floor plan, how densely it is populated with the ducts, light fixtures, diffusers, detectors, speakers, lot of items in the false ceiling, and all these things are coordinated. And you can see this is an extract of the 3D. See, before coming to the stage, I said that first we need to do it in the single line on a hand sketch or on AutoCAD, and then to stage 2, and this is a stage 3. So then you will see a well coordinated product which is going for the execution. And you can see the lighting layout here, RCP pattern, where the light fixtures is coordinated with all the diffusers and other things, and you can see the 3D extract of that area. This is a typical terrace plan, where the terrace in any of the building, you can see the chillers and then the cooling tower, and these are all the scrubbers what we keep. So terrace also is one area where extensive coordination is there among all the discipline with the architect and structure. We need to have an agreement on each and every place, because you need to have a proper maintenance access for each and every equipment. At the same time, it has to be properly coordinated. And this is the rising main, where I am vertically rising my power up to the terrace. So this is a classic example of how the shaft is coordinated well, so that through and through I'm getting it. It is not that from here I will just take and then take an offset to the another location, rising it again like this, coming like this, going like this. That's an improper coordination. The proper coordination is having a shaft through and through and cut out through and through, so that in one single line you can take it. And these are all the extracts from the bin where the services are coordinated. This is a cable tray, this is the fire pipe, this is the PHE pipe, and then there is an agreement. As you all know that there is a rule. The preference has to be given to the pipes which are on gravity flow. So the PHE pipes are given more priority with respect to maintaining the levels. Electrical is the most least with respect to the cable tray routing, because that can bend. Only thing is I need to take care of the bending radius, and at the same time for the fire, he has to comply to the statutory norms with respect to the detector and the sprinkler coverage. So with these things, dynamics in place, we coordinate and agree on a amicable solution. See, this is the executed photo from one of our projects where you can see how, because all these things are possible only when you coordinate properly at the planning stage itself and at the detailed design stage. And then the outcome, you will get an outcome like this, where it is nicely coordinated with all the clearances. You can see very nicely how it is coordinated with all the clearances. This is a typical electrical room, and this is a typical floor electrical room where this is the rising mains of the tap off. You can see here, and these are the bus ducts. This is a close-up view of the rising main. This is a UPS room where I have to coordinate properly with an architect there, because we have a raised floor here. And these are the trenches for getting the cable trays wherever I have the cable with the bottom entry cable with the bottom entry. So these are sections what you can see here. And as I said, this place is for the maintenance, and we are proposed with a 3-tier cable arrangement. So you need to have this space for that. Any operating person can go down and replace some cable if it is required at a later date. And these are the sleeves which I need to coordinate with the structural people. And see the cable tunnel, how extensively it is coordinated. So all these things we need to sit across on a workshop and understand each and everybody's requirement. And this is the cable duct bank, and I need to have extensive coordination with the structural people. These are all for the cable, how we are getting it. This is for the next, this is an excavated trench arrangement. This is an RCC trench arrangement. This is the cable tray in the ceiling level. This is the final distribution board where the conduits. All these things you can see here. This is an in progress site photo where all these things are extensively coordinated. See, this is an lighting where you can see it with the architect. We need to have a coordination, ensure that aesthetically this area has to be appealing. And these are all very heavy light fixtures. So with structural people, I need to see how it has to be suspended. At the same time, as an electrical engineer, a lighting engineer, I need to ensure that the illumination is also taken care, because this is not only an aesthetical lighting, this is a functional lighting too. So see the challenges of what we all have, and with the proper interdisciplinary understanding and coordination, this kind of thing. You can see this in the Mumbai International Airport. And these are all the internal lighting, RCP coordination office area, lift lobby office area. This is inside a room, guest room, dining area. See the facade lighting here. Because the architect will give this design intent. I want the facade to look like this in the rendered image. To bring it to reality, it is not that easy. I need to find a light features which is suitable to that, and I need to see that how it is integrated with the facade elements, so that you get the intent what you rendered will appear once the project is executed. These are all for the external areas. Landscape is another area where lighting is predominantly coordinated. This is on with respect to the earthing and lightning protection, where I need to coordinate with the structural guy. At the same time, I need to coordinate with the architecture, so that the functionality is also taken care. At the same time, the aesthetics also taken care by locating my air termination rod. At the same time, by integrating this rod with the roof on the RCC slab, or the RCC roof, or on the sheet roof. And these are all the earth pits. I need to coordinate with the architect with respect to the location, as with respect to the manholes, right? So with this, I just complete my electrical. These are all the major things which we coordinate. So you can post your questions in the chat box. We will answer you at the end of this session. Thank you. Chakradhar? Chakradhar? Am I audible to all?
Yes, sir.
Yeah.
Yes, sir.
I am done with electrical.
So thank you very much, Mr. Karthikeyan. I hope you all like this amazing presentation. Now, Mr. Karthikeyan will answer some questions that were sent to us during the presentation. If you have any questions, please unmute and ask.
Good morning, sir.
Hello.
This is Arvind, architecture.
Hi.
Can you give a brief about actually how to step down the electrical supply to the building actually?
Yeah. Step down the power.
Power.
Yeah. See, as I said that a transformer, either a power transformer or distribution transformer, transformers are the equipment which steps down the higher voltage to the lower voltage, right?
Yeah.
Let me just share the screen. With that thing, I think you will have a clear idea. Hold on. Is my screen visible?
Yeah, sir, it is visible.
Yes. You see here, as I told, the incoming supply, it could be of any voltage. It could be 220k kilovolt. It could be 110 kilovolt. It could be 66, 33, 11. So these are all the extra high voltage and high voltage category. Okay. So the moment based on the type of voltage, finally, it comes to the transformer here. So transformers is an equipment which steps down the higher voltage in the lower voltage to 415 volts. The power supply, the voltage level what you have at your home is also 415 volts. Because in a building where the load is huge, so we need to have a panel in place because the loads are huge. I need to break down the voltage into the distribution level, and then finally it gets into the MCB distribution board, and then it goes to the, what is your final load? Ultimately, it's going to be your lighting or sockets. So finally, are small equipments like your exhaust fans or some equipments where you need to bring the super vacuum, like the kind of things. So that is where I need to bring. Okay.
Hello. Good morning,
Yeah.
sir. So I want to ask you on how much load we have to provide a proper substation in a building.
It depends on the type of the building and size of the building. Based on the application of the building and size of the building.
Heavy industry building or commercial building?
No, commercial building also, you need to tell me the size. See, for example, if it is a single bedroom flat, okay.
No, sir, I think it's a 250 kilowatt minimum.
250 kilowatt for what?
Load, total load.
No, 250 kilowatt, you need to work out why the 250 kilowatt, how the 250 kilowatt is arrived. Okay. So you can take in any of your buildings where the DLF is constructing an office building, or somebody, Tata Projects is constructing a service apartment with G plus 10 floors, let's say, and every floor you are having 10 flats, 2-bedroom flat or 3-bedroom flats. So multiply by 10 floors. So you have 100 flats. So the electrical engineer, first what he will do, he will work out the load for one flat. So when he is work out the load for one flat, he will assess how many light points I'm going to give, how many power points I'm going to give. He will work out. So if it is 10 light points, I will put for each light point 20 watts. Because since LED has come into picture, we can go with 20 watts to 10, 15 watts, 20 watts. So 20 into 10 points, it is 200 watts. Same way, how I have to arrive how many sockets I'm giving. So every socket, if it is a 6 amp socket, I will consider 100 watts. And if it is a 6 amp socket, I will consider 300 watts. So I will multiply with the number of sockets. I will get a load. Let's say both the loads put together, it is working out, it is summing up to, let's say, 3 kilowatt or 4 kilowatt, let's say 4 kilowatt. All these loads will not work simultaneously. So you need to apply a diversity factor for one flat itself. So let's say I'll apply 50% diversity factor. So the 4 kilowatt load will come to 2 kilowatt per flat. So then multiply by the number of flats. So let's say there are 100 flats are there. So it will come to 2 kilowatt into 100 means it is 2000 kilowatt. Again, I need to apply a building diversity factor there. So on the 2000 kilowatt, I will apply a diversity factor. Let's say all the flats will not work, people will not will be off at the same time. So I will apply a 75% diversity factor. So what is 75% of 2000 kilowatt? 1750 kilowatt. So 1750 kilowatt is the demand. I need to check, and then I need to check with the local electricity board norms. What is the regulation calls for? And at the same time, I need to have, if it is a residential building, I need to see what are all the metering options I have. See, you have metering options, HT metering option, you have LT metering option. If it is an LT metering option, so all the infrastructures will be created by the electricity board, and only you need to pay the money, because all the distribution they will take care. Yes. If you're opting for an high tension metering category, you need to create all the infrastructure following all the norms, and then you will pay in the HT, and then low side you will have an association, they will take care of the LT metering. So this is the arrangement you need to go through. Is that clear?
Thank you. Yes, sir. Thank you, sir.
Yeah, welcome. Any more questions?
No, sir. No more, not from us.
Okay.
Okay, thank you, Mr. Karthikeyan, for answering those questions and for the great presentation. It was a pleasure to have you with us. So now here is our second guest, Mr. Madan. Mr. Madan is a Chief Engineering Manager, Civil, Larsen and Toubro, Buildings and Factories, Chennai. Mr. Madan is a civil engineering graduate, 20 years of experience in public health system, design comprising of airports, railway depots, stations, information technology campus, hospital, educational institutional buildings, residential, hotels in India. He is familiar with Indian standards as well as international codes and standards. Mr. Madan has worked in major organizations such as Mott MacDonald, Orwell. Mr. Madan, share your screen and start webinar.
Yeah, thank you. Thanks for the nice introduction about me. I hope my screen is visible.
Yes, sir.
Yeah, thank you. Yes, as she has given a brief introduction. Yes, I myself, G. Madan, working as a Chief Engineering Manager in Larsen & Toubro. I have 20 years of experience in this field. Basically, I'm a civil engineer, but practiced as a public health engineer. As she said, one place where I was worked, I think the name called, okay, she might have not pronounced properly. I'll just correct that. The place called Auroville, where I have been started my career. See, I think most the architects are, in my opinion, maybe this is one of the place where the Auroville, what I say, it is a place in South India, probably close to Pondicherry. You might have been visited. Maybe you can plan for a visit also, because it has a good amount of architecture, so that there are a lot of external people who can, I could say the external people, meaning the foreigners would have been stationed there, and they are devotees of our this Auroville, you know. So they have their own setup there, and they are making some development, and they are doing some service in Auroville. So that's the best place I can say. Maybe if you have a chances to visit Auroville, just have a look, and you can find a lot of architecture things. Okay, so let's move on to our subject now. Yeah, I think this slide, particularly our friend Mr. Karthikeyan would have been explained you. So I'm not going much time onto it in this particular slide. Hopefully, yes, this is also maybe an MEP service. So we are all part of that MEP service under this. Let me open my. Yeah. So currently we are going to see under this public health engineering system. Yeah. So what PHE does and what it has it's on its hand. Say PHE is responsible for to deliver the safe water in a good quality, and it generates hot and cold water and supply to the buildings, and it has a water saving phenomenon has to be followed, and how to reuse it, how to reuse that water, and what way you have to keep the drainage in a building in a good to maintain a proper sanitation condition, and the kind of water and wastewater treatment plants, what to do in the buildings as well as community, then stormwater management around the buildings and around the project. Then we have regulations which will force us to go for a rainwater harvesting. And yes, there are a lot of modern requirements and the very stringent requirements where the waters are consumed and it should not be sent out because of so many reasons. Since we have been generated more amount of water, extracted some more amount of water, it should not be delivered anywhere outside. So there the concept has come from as a zero liquid discharge, where from the authorities there should be water generated inside the building must be utilized inside the building. You should not dispose it to outside where it will become a higher potential to the municipal drains. And additionally, this solid waste management under PHE is taking care of, and then landscape irrigation and other water features, which is also comes under PHE. This is the normal PHE works, which normally does in any of the project. Yes, we do use the following standards. The primary standards I could say, which is a National Building Code. Yes, again, the second standard I could say maybe the SP35, what most of you people might have heard. And apart from that, there are treatment plant codes are all from the CPHO, which is the water supply and treatment, and for this sewerage and wastewater treatment. And of course, we have solid waste management. And very recently, maybe many of not even aware, the CPHO has introduced this stormwater drainage manual also. And it has a lot of information. It gives a lot of clarity now. So earlier we used to go by our experience and we used to go by our kind of whatever we have seen or whatever the thumb rules followed. And now there will be some document which we can really refer, and it can be used for any other approval process, and other authority regulations can be adopted through this system, through this manual. And another one is the Uniform Plumbing Code. Yes, it has a good information. Maybe you can see a lot of examples and things which are all majorly you may not see in the other standards. And here you can see this will give a good idea about the plumbing connections and all those things. And of course, yes, BIS standards we have. In addition to this, yes, respect to the locations, we have to follow the local bylaws and some of the MOEF approvals and rainwater harvesting manuals separately, what has been released by the Central Water Board. And then we have Energy Conservation Code. Yes, of course, we work for the Green Building Certification also. Yes, coming to the coordination with others, with respect to PHE, you can see a broad amount of work, or in terms of percentage, I can say. Yes, majorly today with you people only. Yes, architect has a major contribution with the PHE. And yes, for the structural, we'll have a 30% and remaining other disciplines approximately a 10% of each. Yeah, the major interface with architecture for PHE starts from the master planning itself. Then, where and all the storage requirements has been placed and treatment facilities were placed, and then solid waste management, how the waste will be taken from the building and where it will be transferred and how it will be managed. And same way for hot water generation is another key things where it requires where the high altitude areas and the low cold regions, And when it comes to the building, we have a toilet spaces and space for shafts, and we'll have a roof drainage coordinations and terrace level coordinations. And of course, yes, general aesthetics of the building with respect to the PHE services, mostly on the peripheral facade or wherever the shafts are coming in and going up. So those areas, this interfaces is going to be happen with our architecture. I just show some general master plan to depict. See here, it's one of the facility what we have recently worked on, and it's a sports facility. Of course, it has a kind of a semi-terrain, I can say. It's not a full hilly terrain, but it's a semi-terrain. See, the basic arrangement of all the other facilities has been highlighted in the different locations. Particularly here, what they have made is a complete set of supply, means the water treatment plant and the storage tanks and everything. They just kept in one of the highest elevation. So which has its an advantage for the complete such a large facility will have a big advantage by keeping this as a kind of gravity supply you can easily envisage here. So that will help you to reduce your lot of power, and a lot of cost saving will happen here. So in the similar nature, if you see in the master plan, they are located as a lower contour for the STP, where the major facilities of this entire building has been, the waste has been generated and diverted to the STP. So I am saying this will have some good advantage for the project as well as for the owner of this facility, or whoever the persons who are all using this facility. It has a good benefit to them. So basically in the master plan itself, if you suggest everything in the right place or right location, the more advantage we will get into it. Okay. So next thing is on the master plan, what majorly the architect has to do to review on the master plan, and what way they have to plan. Let's say they have to do primarily the contour study of that area plays an important role, because the contour will tell them that how the terrain is being planned and placed, and where the facilities, what they are going to plan in that terrain can be located. Last slide I said, so like that you can plan your facilities, and you can easily put your thoughts, so that it will be easy for the project movement and the building's location. All you will find an advantage into it. And the next important thing is, once you see that, then the next point you have to see primarily with the high flood level, which is a very, very important thing which you have to identify, and what is a current surrounding areas and all, what is that history of that area, whether it has any high prone flood area or it is a normal area. So because nowadays, based on the climate change and other things, you cannot predict when the rain will be at a very high level in this zone or something. Yes, of course, we have some data, but yes, in the current scenario, it is very, very important. You have to assess this factor as one thing. So this definitely will help you, that where the buildings entries and exits, in consultation with the PHE team, you can fix with that, so that our PHE also will help you whether this level can be fit enough, or maybe this much flood level is beyond this fit level, how much you can move up, what is the level you can maintain it. Next thing, as I said, yes, any overhead tanks which could be at the higher possible level, and same way the STP is on the lower part, this thing. And sewage, as I said, sewage must flow through gravity. It will have a lot of own benefits. And stormwater, of course, it should go under gravity, because it's a huge amount of collection which you are not afford to pay on a power or maybe a pumping. Of course, yes, where you don't have any option, then you have to do it. And these road cambers and slopes also, you can consult with the PHE, you can fix it. So this is the key elements which you can mostly consider during your master plan. This small picture I just put it, for example, if suppose there is a new development, if there is an area where you can find there is an area where the water courses are there and which is flood prone zone, then probably what you can do, maybe the adjoining areas you can slightly fill up, or you can build up, so that at any flood level it may not reach to your facility to get a disturbance. Or probably you have to see whether I can shift away from that certain distance based on your flood data. You can decide how far it can be. okay, this is one kind of a new development. You can all this arrangements you can do. But for sometimes when there is an existing what we have to do, then if it is a perennial issue with that every year you are finding this kind of problem, either one option is you could remove the nearby facility, which can be, I mean, it's an option only. We cannot say that this is the only way to, only way is available for this. Probably these tenements can be removed from this particular area and make some kind of flood retaining structure if possible, or maybe some amount of nowadays you can see a lot of good techniques around where we can lift the buildings also. This is could be an option for a flood prone areas which you can think about it. Yeah, coming to this, the storm and all, if you see primarily the storm runoff, immediately what you have to do, it has to be drained. So for that, what you have to do during your master plan, your road and other adjoining areas to be in a properly sloped, and where the drains and all there and the roads and all, you should have maintain a proper slope. So slope is an important criteria where IRC also recommends approximately 2 to 2.5% of the slope should be maintained on the road. It cannot be a flat road, because otherwise what will happen due to regular use and due to the climate change, your road may tend to act differently. So definitely you will find a lot of hindrances on the road. There should be a longitudinal slope. If your terrain permits, you can follow the terrain. If not, if it's a flat terrain, then probably you can go with your minimum 0.3% of the slope to get the stormwater to get away. And some aesthetics also you can plan during the roadside, probably with the stormwater entries to the drain. Probably it's the combination of I can say that is a topmost entry of the water is also possible here. Sometimes the side entries also can be planned for with respect to the condition and location. Maybe both cannot be there at everywhere. Probably if the location is very quickly to be drained, then whatever these both top as well as side entries could be a ideal requirement. So next thing is, yes, there is a landscape which part of your master plan development. What you have to do and what you have to think is let the green cover should be at least 20%. You should plan for it so that it will have a good ambience around the project or around the development what you are going to do. And try to find maximum as much as native plants and the trees which can survive in the local condition, so that it consumes most of the time. The plants which you are bringing from outside, or probably which is not suitable to the indigenous location, it may die, or it may consume sometimes more water to make it live. So for that reason, I think better to have the native species so that it will have some less amount of water, and if in case of any water stress also, that will help you. So coming to that water reduction and all, if you want to talk on the landscape, then probably the landscape could be an automatic type so that it can be controlled with controlled with some kind of sensors and other things, so that it can use a minimal water, and it can be a right time you can put the water for the plants. So most of the water saving can be achieved through drips as well as sprinklers. And yes, of course, during your master planning, you can think about your water bodies and water features, where PHE can help you how to make the filtration for it, and how to bring out the water clean and making a proper circulation into it. Yeah. Next thing is coming to water requirement for the facility. If you see, for a building, the water is the most important thing. I think most of our buildings are breathing only with this services requirement only. Whatever the service, if you put, whether it is electrical or what the coordination details, what we have seen earlier, along with architecture, these services should be there, then only the buildings can breathe. So primarily, if you see, the water is a prime important requirement for the habitants. And the water, yes, if you say what kind of water to be provided for any any water we are supplying to the building, it should be free from contamination, and it should not have any physical and chemical harmness. So for that, there is a standard. What we normally follow is 10,500 is the standard, which will give the what kind of parameters for the quality of water to be maintained. To estimate a demand for us for any type of building, NBC provides some guidelines. So I think through that only we have to assess. Based on that, I just listed out here. Let's say, for example, if you see a residential building, range of 90 to 155 LPD for a domestic demand it requires. And if you split the demands in two ways, like a flushing also, then you will have a 45 liters which is required. So total LPCD, if you see, then probably a person can consume around 135 to 200 liters based on the difference of the category of the residence and the location. So similar way, if you see the hospitals, if anything greater than 100 beds, the same NBC says for the split up of 300 and 150 for domestic as well as flushing, and it reaches to close to 450 liters per capita, per bed actually for a hospital. And apart from this, what we have to do, there should be a separate assessment we have to make when there is a kitchen facility available, and there are clinical facilities and laundry to be separate, and a huge water consumption in the hospitals. So for this separately, you have to arrive. These are all going to, again, based on our previous data and the consumption data, what has been available from the existing operating hospitals. From there, we can arrive it and we can go with the calculation. So approximately, I can say this 450 per bed will reach closer to 600 to 800 also, with the addition to this, approximately you can reach. But NBC says a minimum should be this much, but you have to assess by your own and then you have to put it. So similar to for office nature, yes, total is 45, which already covers kitchen also, because most of the offices will have the canteen facilities where the food is prepared for the employees there itself. So this demand is already included here. Yes, of course, hostel, which is almost similar to your residential nature, same of 135 only, it is going to be used by the students. And coming to other facilities, stadiums, if you say that 4 and 6 as a total of 10 per seat, and it has other facilities, probably we can refer into the NBC and we can take the water assessment for the particular building. Okay, apart from other requirements, we can see for any building, there are building cooling water we have to provide as a PHE, because for our HVAC team, or maybe the recent, or I can say the strict guidelines are all there, we should not waste our water, it should be reused. So majorly the other wastewater can be treated and it can be consumed for the following purposes, kind of a building cooling, and wherever the DGs are there, whether the DGs can be cooled with this recycled water, and where we require a lot of washing, particularly on the road or the floors and any terrace, and there you can use this. And some amount of water is also getting used for your treatment plant, which is required for some backwash activities. And this thing, landscape irrigation is another prime requirement in most of the projects, because a lot of areas has been put up with landscape for that. So put together, apart from your regular domestic use, and this is additional requirements of water, you have to plan for it, and the spaces and other things also, it has to be coordinated with the BH. So based on this, you can fix what is the total storage volume you can keep for your facility. Now we'll see why the storage tanks are mandatorily required for each project or each development. See, it will make you to the water supply to continuous. It will avoid the intermittent supply. So if you have that storage, you will get a regular supply, so that and it will have a minimum fire reserve also you have to maintain in the building. For that also it is required, and it reduces some amount of demands in the pipe sizes, and total maximum demands it can be reduced, and the maintenance schedules and repairs, so that during that time the storage will help you. And any emergency situations like your power cuts and damage to your infrastructure sometimes may happen for any reason. So that time the storage part should be helpful to you. So mandatorily the storage has to be there at each and every facility. So since that the storage is minimum, yeah. So now as we seen some storage, so storage should be of at least this 1.5 days of demand as per NBC India recommends. This says that at least 1.5 days you can put it in your sump, which is on the bottommost portion. And there, if suppose you have an overhead tank, then at least you keep for a half-day demand. Sometimes you will have a raw water quality and a treated water quality and various different purposes and all. Then accordingly, the sumps and the overhead tanks can be splitted with respect to the demands and the requirements. And what architect basically see when there is a storage sumps are there should be a proper access to that area, and some of the inspection areas we can be planned. And most probably these sumps and things all should be covered with vent pipes, overflows and scores and inlet outlets. This needs to be a primary requirements for a sump and the pump room to operate for the facility. This image which you can see there are some firewater tanks which is there, and followed with the raw water tank, and in between there is a space which can be planned for plant rooms where this raw water can be sucked out and it can be treated. Then it can be pumped back to the domestic water tank. Again, from there it will be pumped to the respective uses. Similarly, we have some freshwater tanks and HVC water tanks. I mean, these are the other tanks what we have seen in the previous slides. Means the other demands. It's not only that only for a domestic purpose. As I said, the building cooling that comes under this. Probably this may similar nature. It will go for a electrical cooling also. I mean DG cooling. So here I just show a small worked out example so that it can give you some amount of idea how this water demands are calculated. So we have seen some various per day requirement of, let's say, for residential 135 and office and all 45 and hospital is close to 450. Yes, that is a total. So when it comes to a building, how this water is being calculated in the building. Say suppose for an facility which has a 10,000 square meter area. So approximately what we can do here, a 10 square meter per person can be considered, so that this 1,000 numbers can be accommodated as a population in that particular office building. So when we say that 1,000 people are occupied, then how much water can be kept for them, or kind of a storage we can plan for them. Let's say 45 is our overall demand, where we have seen is 25 liters of our domestic demand is required, and 20 liters of our flushing is required. So by just simple multiplication, we can get as a domestic water demand as 25,000 liters. And yes, we have added some 3% of extra demand, which is primarily going to be used when there is a treatment facilities are going to be there. In that case, then there should be an additional demand of 750 is required. This I can say is a kind of a standard practice we will follow. So in the same way, there should be a flushing water also, since we are using as a domestic separate water and flushing water separately. So how much this amount of water could be, that we have seen as a 20 is for flushing, so approximately 20,000 liters. And then in addition to that, what is that requirement in that particular area? If you see probably a landscape, I can say that also close to 1,000 square meter is a landscape area planned. Then as per NBC, if you see approximately amount of water you can plan here per square meter could be of 6 liters for irrigation. So by this, if you see, you may require 6,000 liters extra. Then as I said, some other requirement where the building cooling is required, let's say some input from our HVAC team if you are getting, then probably that amount you can say it's just a tentative figure I just added here. So that also you can add. So finally, if you see putting together, then overall to the STP, how much water will become wastewater, then how much amount of water it will reach to the STP. So approximately, I mean, not approximately, we can say as per the standard, the domestic water, we can say it's a 90% of the domestic water will go to the STP, because this water is being consumed by us, and it will be a lot of losses and other things are all happening. That's why this become a 90%. And 10% of the flushing water, yes, of course, it comes to the fixture directly, and it reaches directly to the sewer network and reaches to the STP. So that's why that's become 100%. So put together, if you see this much amount of water, it will, I mean, sewage will be generated. It will go back to the STP. So when you say that from STP, how much water I can get it for my further use, you can say approximately close to 92%. You can say this water can be reused for further applications. Why it is 92? Because there will be again a losses, and during the STP process, you will find some amount of losses during sludge segregation, and there are losses and other things and all if you go. So approximately you will get this. So by seeing this, you can, I mean, by doing this, you can arrive how much amount of water can be consumed by the facility. Small balance chart as a sample balance chart with this same calculation I just added here to for your understanding in a simple term. Raw water gets in is of this much, because we have seen it's only 25,000, but actually we need for a WTP backwash also. So that's why this total has become here. So then it reaches to the WTP, then it is getting splitted into 25,000 liters, and that's a backwash goes off. As we said, it's 90% goes to that STP back here, and same backwash also is getting into this. During that STP process, there will be two segregations will happen. One is the sludge and one is the treated water. So sludge could be approximately calculated to this 3 to 8% of this. Then we'll find the treated water approximately after the sludge goes off. Then you can find approximately 40,000 liters. In that, you can see we have already calculated the flushing demand of 20,000 can be used, and cooling demand of 19,000, and irrigation of 6,000. So this flushing again, where we are going to use it, it is going to the building, and it will again back to STP only. That's why that A depicts here. Actually, there should be a recirculation happens in this particular water. But of course, this cooling water, when it goes off. It will evaporate, or during any particular cycles of concentration, they will remove this water and it will go to the drain or somewhere. And same way, irrigation water, when you put it on the ground, you will not get back anything. Sometimes you may find an excess water where you have to decide what you can do for this excess water. Either it can be resale to the water company, or probably it can be disposed in further any available network for you, so that you can dispose of. So this, I hope it will give some idea in what way you can calculate and how the water balance works for the public health system. Now, coming to the treatment side of the water, if you see what kind of treatments can be adopted for various types of sources. Let's say normally we got it from municipal supply. If municipal supply, more or less the government will supply the source, it will be fit for our potable application only. So what we can do, we have to do basic filtration and disinfection. By that we can that type of treatment you can adopt it, and it can be used further. Same way for open well sources, the treatment again will be differs with a little bit of filtration to remove in case of any kind of color or some differences there. Probably this carbon filtration will help you, and of course we'll go for a disinfection before it consumes. So with that you can the treatment can be planned. And similarly, like other sources of lakes, rivers, and ponds, and there will be find a lot of impurities. So typically there should be a settlers we have to plan, and followed with the sand filtration and disinfection. And predominantly in many of the projects, we will get only bore wells. Maybe the lakes and rivers are all very rare, and open wells also very rare. Municipal, of course, yes, we will get. But predominantly, if you see, bore wells is our prime source in many of the projects. And it requires a lot of your water analysis. Based on the water analysis, the treatment will be decided. So primarily, if you see the sand filtration, and if in case hardness is there, then you have to go for a softening plant. And sometimes the water is of more high TDS, then there you have to go for a TDS removal plant, where the TDS only removed through RO process, what we call it as a reverse osmosis. And when you go for a situation where you have to use the seawater, then you have no other option. There should be a desalination plant. Of course, it's work for the desalination activity. That's why it is called as a desalination plant. Otherwise, the simple terms you can say it is an RO process only. And there are some other special treatments required when after the analysis of the water quality, then you can find whether the iron content what it is and the fluoride content what it is. Based on that, you can decide whether iron removal is required or fluoride removal is required. So it is totally based on the local conditions of the water what you are getting. Okay, approximately here what I can say, there is a range of water depth for the sumps and all. We can keep a range of 3.5 to 5 meters. By this, based on our previous slide calculation of our total sump volumes and all, then you can fix this could be a tentative depth for your sumps and all. Then approximately you can place the master planning in your during your master planning, you can fix how much area it can be covered for this particular
Madan,
so
I'm Madan Chakradhar here. Madan, we can start the question answer session in the next 5 minutes.
Okay.
Okay.
Yeah.
So I think so the next speaker is ready.
Okay.
Yeah. Thank you.
Okay. Right. So similar way in the water treatment, we have a lot of criteria to be followed with respect to architects, where the surrounding spaces needs to be maintained and proper access. And when there is a sumps where you have to use your food grade linings and food grade epoxy painting can be planned. So these things and all you have to take care in your storage sumps and any WTP requirements. Same way for STP, as I said, the 80 to 90% of the water comes to the STP as a overall, and the STP is primarily removes the BOD, COD, and the suspended matters. So based on this characteristics removal, and we have to do some analysis based on the quality of sewage. Again, there should be an analysis to be done, and the type of STP also will be decided based on the quality of your sewage, and you have to make a separate analysis for it and what kind of process can be provided, and it is suitable to the location and condition. So here I can say yes, there should be again some good aesthetics has to be planned around the STP areas, and some other facilities like a laboratory and equipment movement space, and all those things needs to be taken care by the architects overall. And I'll just give some space requirement for an STP. It normally ranges per KLD. For KLD meaning it is approximately 1,000 liters of sewage if you are generating. Then you need a close to 0.6 to 1.6 is the range. It's a wide range only. Yes, of course, it has a various technologies we are following in the STP. So based on this, you can, if you arrive at total water demand, and from there you can put a 90% of that, you can get the STP capacity. Then you can decide how much space it can be occupied by the STP. So space-wise, I can say here the modern technologies are use the lesser spaces, and the quality of treatment will be slightly not so superior with respect to the conventional technologies. But of course, we have a lot of other factors so that we are choosing based on the space and the quality requirements and what the process has been decided. Some of the process I just listed here, these are one of the oldest technologies, and these are the modern technologies. So this will give some idea. Coming to the solid waste, yes, solid waste again split into biodegradable and non-biodegradable. Yes, of course, biodegradable. We all know that it can be decomposed, and the non-biodegradable has to be properly treated and properly settled to the respective recyclers. So that's the way we have to handle this solid waste. yes, with the generation of yes, solid waste, how it has to be done, then probably we have to see with respect to the NBC, there are the capacities has been defined with the various type of building and the various type of uses. These are the range. And from this capacity, you can say 40% can be considered as your organic and 60% could be an inorganic. And coming to this, the organic, the solid waste thing, probably the latest technologies you can say there is a chute and there are chute systems are all you can plan. And we have some kind of a pneumatic waste solid system where you can have a lot of areas where the waste has been dropped, and you can see from the building, you can see from the street, and finally it goes to the central facility. This completely functions with respect to the vacuum system. So again, based on the capacity of the, based on the quantum of the waste and other thing, we have to decide the space and the areas around it. Yes, this is one of the modern technologies what we have, many of the projects as getting used, called as a OWC, which is organic waste converter. All the organic waste converter, all the solid waste, the degradable waste, if you see, it can be treated in this, and from this treated output of this waste can be used for many purposes, like for your landscape, the manures and the soil blenders and all, you can use this. And coming to the next thing inside the building, probably you can see mostly the PhD team which sits with the architects on the toilet fixtures, this thing. So here I'm not going much time. Then yes, once you arrive the population of the building, then probably you can segregate the percentage wise the male and female. So based on this category, you can fix the fixture. For an example of an office has been given here. Let's say for a WC, if it is 1/25 for a male, and a female if it is 15. So like that, we can fix the fixtures under here. And next is another, there are various types of fixtures which are used, and primarily we can say there is some emergency eye fixture, which I put it here because it requires in the where the hazardous areas where the building is handling the hazardous things, and all this is primarily to be put up. And of course, yes, some specialized features fixtures also has been used in the buildings, so that probably you can plan for the spaces. Yes, of course, the hot water is one of the prime thing which is required on the high altitude spaces as well as the low temperature zones. Of course, this can be generated in various forms like the solar, hot water, and the heat pumps. So, of course, based on this generation, we need some space from the architect, either from the terrace side or where the sufficient space is available for the solar tubes. Tentatively, I can give some idea here. 100 LPD requirement of solar, which can consume a space of 1.5 to 2 square meter. And typically, this one panel can generate close to 125 liters of hot water per day. So other hot water generators are the modern things are all like a heat pumps, which is a reverse technology of your refrigerator. Like it will take the external air and it converts the heat. So like through that you will get a hot water generation. The same way for your hot water boiler also. So these are all some available technologies for our hot water generation. But of course, yes, it requires a space from architects, and it should be planned with PhD. The next important thing is, yes, inside the building, it is a shaft. See, most of the places, the shafts are all planned with architects. I can say most of the places where the functional spaces are defined and where the left out spaces primarily has been kept for shaft. It should not be do like that, because it requires as I said, with this only buildings are breathing. So when there is a problem, so people has to be attended. So there should be a importance has to be given for the spaces, so that tomorrow at any point of maintenance and accessibility is a prime thing, so that only the downtime you can reduce it. So in general practice, the minimum shaft width should be at least 600 mm, so that a man can move a little bit freely. Depends upon the arrangement of the washrooms and the wet areas, you can decide at least what width is required. That PH team can help you, so that with that you can go for it. This is some typical arrangement. And next, move on to the roof side. Yes, roof is another critical thing where the stormwater which will collects and where immediately the rainwater has to be removed from the roof. Normally, we work with the slope for that, and that slope needs to be minimum maintained as a range of 1 in 150 to 1 in 133 as per the standard. And of course, it has to have a proper outlets, has to be designed so that PHE will help you. But yes, the slope and other categories and other drain areas and all has to be planned with respect to architecture. There is another modern system. Hopefully, you may all aware of it. There is a conventional drainage. What we seen in the previous slide will have a pipe, and the water will flow into it. And very recently, in a very high roof area projects and all, this siphonic drainage comes in a place where probably you will get 100% of the water. The siphonic system gives an advantage when the pipe flows the rainwater with 100%. When the conventional, you can say it's only hardly 30 to 33% of water only. Remaining all will be air only will move into that. So this system has good advantage when we have a large area and it doesn't require major slopes also. So this will help for the users as well as for architects for on the ceiling side and many aesthetic side also. This will help. Yeah, I think with this I can close my thing. Probably any queries I can answer.
So good morning, sir. Sir, yeah. Actually, we are discussing more about large scale projects. Actually, even second level towns, actually small towns, where actually we provided there won't be any drainage system. Can you give some septic tank and all that? Actually, can you give some design over that?
Your voice is a little bit breaking. I understand that you are working in a large area projects.
No. I'm not working in a larger scale of works. I'm looking for the small towns where actually we have apartment capacity of 20 flats and like that.
Okay.
Any drainage system. So mostly we are going for septic tanks like that. So can you give brief about some notes on STP? Not STP, it is a septic tank.
Yeah, see, septic tank is one of the oldest technology, and maybe you can use for a smaller application. There is nothing wrong. But the only thing is the problem with the septic tank is you cannot hold the sewage for a very long time. See, it has to be decided based on the occupants, how much you are going to use. As you said, approximately 20 flats. Per flat, you may say 4 person. I'm taking an average. Okay, so 20 means approximately you can say it comes around 80 people in a flat, correct?
Yeah.
So since it is a residential, in our slide also we can see that 135 liters as our base demand if you consider. So that 80 people into 135 liters, if you put, the amount of volume you will get is close to 10,000 liters. So approximately if you see so approximately if you see the septic tank which you can design, what will happen, the daily usage of your the daily waste, whatever has been generated from the household or from the human excreta, which has to be collected into that, and actually it needs to be digested. Okay, for that digestion, the septic tank, if you see, it will have some different compartments as per the design. If you go, there will be a seeding of the sludge and there will be a digestion zone. After this will happen, then there will be a kind of a dead amount of water only will come out of from the septic tank. But the problem is, since you said you don't have the drainage system outside, then this water, what you are consuming daily, other than your solids, this water has to be properly taken out and it has to be thrown out. Otherwise, it will be a hindrance for you. So the only option what you have for this to across, you have to go for a what do you call this, soak pit, what they call it as. So that soak pit, you have to arrange it adjacent or probably away from your building, or maybe you can see the space where you can keep this soak pit. So the daily water which is comes out from the after the sludge settlement and everything, this water needs to be properly sent into the your soak pit, where it has to be soaked into the this one as into the ground only. See, this is the only option you have if you go with the septic tank. Of course, based on your solids keeps building into it, so one day the solid also will occupy its volume. Then there is no other option. You have to bring out and bring out solids. I mean, the sewage sucker machine or something, the municipal tankers, which you have to clean your septic tank. So this is the only way you have to handle if you are in the place where you can the draining or the municipal sewer is not available. I hope I clear to you.
Yeah, I got it, sir. Actually, thank you for that.
Yeah.
Whether we have any alternative other than this septic tank, actually, for this small scale and without having a drainage, municipal drainage facility?
Yes, we have some alternatives. As we say, there are some compact STPs. Compact STPs, they will say, are kind of fabricated STPs, where, see, it is STP only. Ultimately, STPs can be designed even for a minimum 5,000 liters can also it can handle. So if your apartment or whatever the low zone, I mean low income, I mean what do you call the low developed area where you don't have this facilities, probably if it is affordable to use this kind of treatment plants and all, then it can be planned accordingly. That can be designed also. That is not a problem. Ultimately, from this, again, as you said, daily you will get the treated water, existing premises of that treated wastewater also.
Thank you, sir.
Yeah.
So
Morning,
for
sir.
water supply, what should be ideal height to get pressure set outlet proper pressure is?
Come again? Ideally,
For, for, for water supply tanks, what should be ideal height to get
okay. See, for any building, if you see with you go as per standard, from a terrace floor, whatever I hope you are planning for an overhead tank. So that overhead tank ideally should be from your floor FFL, from the terrace floor. It should meet at least 2 meter is your bottom of your tank. Some facility you are keeping, there is a shower is being placed, for example. If suppose there is a shower, you need at least some pressure to reach for that shower to operate, if it is for a minimum pressure requirement. If you have any limitations of keeping this 2 meter is my problem, so that aesthetically it won't look good or something, then probably you can look for a minimum meter height also, which is accepted, but you should go with some amount of boosting system for the pressure meeting for the low level zones. So that way only you have to fix it. If you are very much sure that I don't want any pressure boosting onto my this thing, I don't have any issue of my overhead tank can be projected above, then minimum you can keep it for 2 meters. So that only the minimum pressure what we are expected in the highest pressure and the shower could be achieved.
Okay, sir. Thank you. So suppose we have separate water, so we are creating separate concrete tank for 1-story building. Then what could be ideal height for that? It at least around 14 meters we required for.
You come again. How many stories you said? Because I lost your.
We are single-story hospital and we are building separate water tanks for that. So based on pressure requirement, what could be ideal height for that?
See, if it is as you said, it's a single story, so definitely you mean to say it is only a ground structure. I mean ground floor only. That's what I'm meaning, right? Or it's a first floor also you have?
Yes, only ground floor only.
Only ground floor. So naturally, the ground floor above, if you want to keep the over a tank, you have to keep it as a minimum of this 2 meter as I explained. But what type of fixture you are going to use it in the hospital? Whether it is, again, it will be decided based on the your fixtures, like let's say there is a flush valve. If you are going to introduce anything for your flushing requirement, if that is so, then definitely the height 2 meter, what I was saying, will not help you, because the fixture itself requires some higher pressure to operate it. Otherwise, a very basic conventional systems and other, the normal showers, if that helps you with the minimum pressure, you can maintain with this 2 meter height.
Okay, sir. Thank you. Thank you.
Yeah.
Hello.
Hello.
Yes, please.
Sir, how
Hello,
to
sir.
set the pressure in residential building, sir?
Sorry, how to
Set the pressure in residential building, sir.
how to set the pressure where?
In floor.
See. Sorry.
Floor ways up to.
No, I got floor height.
No.
No, I'm not getting your question fully.
4 meters, sir. Floor height 4 meter.
Acha, floor height is 4 meter. Okay.
4 meter. Residential building 10 floor, 20, 15. How to set the pressure, sir?
Okay, you have a 10 floors of a residential building, and each floor you are saying approximately 4 meter, correct?
Yes, sir. Yes, sir. How to set the pressure at floor ways?
How to set or how to check?
How to the pressure setting the pressure.
Okay, setting the pressure. Okay.
Yes,
see, now as you said, your total building is approximately 10 floors with 4 meter. You are reaching 40 meters, correct? No. 40 meters your height of the building. Let's say, for example, your 10th floor, you have a terrace, and for your overhead tank, if you are having, I'm just keeping an example, maybe your actual situation you have to assess. If suppose there is a overhead tank, from the overhead tank, let's say you are supplying the water to your down to your residential floors. Let's say approximately I can say up to your 50% of the floor. Maybe if you drop it with one drop pipe, approximately you can say if all this individual flats will have a single toilet, then approximately you will get with respect to 2 bar pressure approximately. Okay. But at the same time, you don't, when you go to the bottommost floor, approximately then your pressure build up with respect to your static height and with your terrace height, the overhead tank height, approximately you may reach close to 4 to 4.5 bar, 40 to 45 meters pressure. If you feel this 45 meter pressure seems to be a very high or very excessive, where you cannot, when you open the tap, the water may splash like anything. You may not touch the water. It will hit on your hand. Then the only option is you have to use a pressure reducing valve, which will control in your excessive pressure. Probably that range of pressure, what you can fix is approximately a 1 bar can be delivered after your ground floor, so that you can feel that yes, I could use a normal flow of water in my while using. So the option is you have to set with a PRV a range, as I said, approximately 4.5 to 1 bar. That means a range you have to reduce approximately 3 bar of pressure or 3.5 of pressure. You have to reduce through a PRV setting. Then only the pressure will be reduced.
Madan, thank you.
Is it answered? Yeah.
Okay, sir. Okay, sir.
Yeah, hi. Mr. Vijay, wonderful question, and I really appreciate the way the audience are participating in the discussion, because the timelines are there, the schedule is there to complete the overall webinar. We will not be able to answer all the questions, but at the end of the webinar, we are going to give you a wonderful opportunity for you to learn and we will give you wonderful option where you can learn each and every point which you feel you are not able to execute at site or execute in the design. So the overall purpose of this webinar is that we create, at the end we will tell you what are the modules available, when we are going to deliver those modules, how we are going to deliver those modules. All these things will come at the end of this webinar. Okay, thank you very much.
Yeah, thank you. I'll stop sharing.
Yeah.
Thank you very much, Mr. Madan. I hope you all like this amazing presentation. Okay, thank you once again, Mr. Madan, for answering those questions and for the guest presentation. It was a pleasure to have you with us.
Thank you.
So now here is our third guest, Mr. Satyanath Mukti. Mr. Satyanath Mukti is a senior engineering manager, HVAC Design, Larsen and Turbo, Building and Factories, Chennai. Mr. Satyanath Mukti is a HVAC engineer with over 16 years of experience in designing and engineering for various applications such as airports, IT parks, data centers, Malcolm multiplexes, hospitals, medical colleges, etc. in India and FIFA 2022 World Cup Stadium in Qatar. He is familiar with Indian standards as well as international codes and standards such as ASHRAE, ISHRAE, NBC, SMACNA, DW, NFPA, BS regulations. He is prior to L&T associated with major organizations such as Sterling and Wilson, Voltas, Mott MacDonald. Over to you, Mr. Satyanath Mukti. Please share your screen and start webinar.
Yeah, thank you. Thank you very much. Good morning and a warm welcome to all of you. Thank you, Mr. Chakradhar, for inviting us and giving this opportunity to express our thoughts and our sharing our problems, where we can discuss in this forum that how we do the MEP services in collaborative approach with architect and structure. So I'll share my screen. Give me a moment. Is it visible? My screen is visible?
Not yet.
Okay, 1 minute.
Yeah, it's coming. You can make
yes.
it full screen. Yes, perfect. Perfect.
Yeah. So my name is Satyanath Mukti. I have been working with Larsen & Toubro for past 10 years. Currently working as senior engineering manager for HVAC design. I'm into building and factories, specifically for commercial buildings and airports. So we are basically dealing with the buildings. So it will be the regular basis. Basically, we are interacting with architects, structure, and all other MEP teams to sort all the problems and challenges what we face regular basis, while incorporate all our systems into the building design. So moving on to this, my previous speakers already explained. Basically, yes, the architects plays the key role. Rather, I would say they are the boss for any building design. They only who incorporates our MEP requirements, MEP aspects, everything, and they control the building to keep the aesthetic appearances as the client wants. So it's a great challenges for primarily for the architects, and then definitely for all of us. Now I would like to give a basic brief about the HVAC system. I'm going to talk about the HVAC system. So HVAC, it basically defines the heating, ventilation, and air conditioning, as you all know. So the basic goal of air conditioning is thermal comfort for in terms of temperature and humidity, and obviously acceptable indoor air quality for the human comfort and ventilation. So heating provides, where we provide heating is basically in the cold climatic condition, where if you see the northern part of India, where during winter it will be so cold, so we have to provide a heating for the spaces for the comfortness of the human being, and air conditioning obviously in the major part of India during summer, monsoon, and throughout the year, some of the region of India we provide air conditioning, and ventilation, as I said, is for the indoor air quality. So as I said, India is a vast, large country. So it divided into a lot of different climatic zones. If we refer National Building Code of India, it defines a major 5 key climatic zone: hot and dry, warm and humid, moderate, cold, and composite. So depending upon its ambient temperature and the humidity range, it classify all these climatic zones. So when you do the first thing basically to provide air conditioning is we have to estimate the cooling demand for a particular space. So as you all know that we provide like air conditioning through air conditioning machines, like in our household also we provide air conditioners like 1 ton machine, 2 ton machine, 1.5 ton machine, like that. So how we estimate that it is required 2 ton or 1.5 ton or 1 ton or even more. So what are the basically heat source for a building while calculating the cooling load is basically the heat gain through building envelope, and obviously its geometry matters a lot. And then the pressure, which is a necessary requirement for the human comfort. We are taking the ambient air inside the building, so it's quite a large amount of heat we are taking inside. And so as I said, building envelope is basically through wall, windows, roofs, floors, etc. What it does is basically, if you see if you see a particular space, this is the overall building envelope. So building envelope covered with the walls, roofs, floors, and all other things. So the heat gains happens through various methods. So there is a material, it matters a lot what is the material of the wall and roofs and all. Like the heat transfer coefficient is the key factor over here. So the more heat transfer coefficient or U value is there, will allow more heat into the space. So today's scenario, if you see any building is a energy consumption building code, ECVC we follow to it specified the what should be the U value of a wall material, of a roof material. So accordingly, architect also will select its material, whether it will be hollow block, whether it will be solid block, or it will be aerated block, concrete block, or any insulation requirement or not in the wall. So all those things, depending upon those, basically we can optimize the heat ingress to the space, and obviously we can optimize the cooling demand. As I said, fresh air is the major heat source. We cannot compromise in it. We have to provide that. And then obviously the internal loads. Internal loads basically comprising of the lighting, the equipment inside the space, and obviously the occupants. Each and every occupant, we as a human being, we release heats in terms of sensible and latent. So quite a lot of heat we also generate inside the space as per our activity level. So once we know our cooling demand, how much is the air conditioning load is required to cool the space, we select the equipments. As I said, for our household system, normally we provide window AC. All of you, I think, will be aware of this window AC, and you might have seen. So it will be a compact air conditioners, which normally fixed on the wall. So it's all its part of the air conditioning will be fixed here. Then it comes to high wall split AC. High wall split AC basically is the the split up of the inside, which is indoor, and outside, which is outdoor. Means basically it has any refrigeration, any air conditioning or refrigeration system. There will be 4 components, which is evaporator, condenser, compressor, and the expansion device. So basically inside is called evaporator or the cooling device, or where we get the cold air. That is called the indoor unit. So when it is a compact, it's called window AC. When it is a split up, because depending upon if you don't have the external wall of particular room, you cannot provide a window AC. So you have to go for a split AC, where indoor unit we can place as per your requirement, and then outdoor unit you can place it at anywhere outside, wherever you are getting access to the outside wall. So you have a flexibility in that, and there will be refrigerant copper pipe will be connected between these two. So this is basically normally we use in household, and even some of the commercial application also we use high wall split. Now, little bigger form of the high wall split is the ductable split AC, where the capacity of air conditioners become bigger. And it's a ducted split. Why it is called ducted split? Because the air distribution through the indoor unit has to be through ducted system. So a metal duct will be provided, through that cold air will be distributed to the desired locations. And then obviously there will be outdoor unit will be located outside and connected with the refrigerant pipe. Now, in this case, basically it will be a dedicated outdoor versus dedicated indoor, one-to-one system. So if you have a large scale of requirement of a particular building, let's say you have a 10-story building, whether it is residential or commercial building, your requirement will be, indoor unit requirement would be more. So in that case, you have a wonderful opportunity to propose the VRF system, that is called variable refrigerant flow. It has two basic benefits. One is you can serve, it will work as a centralized plant. So you have outdoor units, you can put it at the terrace, and through refrigerant pipe in each floor, each zone, you can run through, and as per your requirement, you can propose the type of, various type of indoor units are available for the VRF units. So that is one thing you can use as a centralized part of it. And the second is why it is called variable refrigerant flow. Basically, as per the demand of inside space, like it will not be always the same load demand inside, depending upon the occupancy, depending on the ambient condition. Like morning, whatever your cooling demand is required, definitely it will be vary during noon time, afternoon time, and the evening time. So depending upon that, it flows the refrigerant to cool the space. That's why it's called a variable refrigerant flow system. These all are basically in terms of DX system. Now, if you come to the chiller-based system, which is basically chilled water system, and this is the large-scale chilled water system where we use in the commercial projects and the large-scale projects. So there are basically two types of chilled water-based systems available. One is through air-cooled chillers, another basically through water-cooled chillers. Air-cooled chillers are normally, you can see it is located at outside, where it condenser is basically air-cooled. So there is no requirement of cooling towers in case of air-cooled chillers. When it comes to the water-cooled chillers, it is required a cooling towers. So we have to identify a space for cooling towers at the outside. So any water-cooled chiller plant, we have to have a plant room, as well as we have to have a space for cooling towers at the outside, whether it is ground floor or terrace or anywhere else we can propose. Now, the different systems involved in HVAC is when we do the building design, building HVAC design, it involves air conditioning, mechanical ventilation, air distribution system, water distribution system through pipings and valves. Then life safety part of it, pressurization system, where staircase, lift and lift lobby pressurization will be involved. Then smoke extraction systems, and obviously nowadays for large scale projects, we have to provide CFD. We have to check the CFD, computational fluid dynamics analysis for the performance-based system, like what you do as per the calculation and as per the system design, whether it is performing and giving the desired temperature in terms of cooling, and at the same time smoke exhaust, whether it is getting all the smokes getting cleared. So we have to check the CFD analysis. As a nice tool, we can use it before it is implemented at site. So that is also we normally do in our in-house. Even in our department also, we have a capability of CFD analysis we do for our large scale projects. So while doing the design, basically we follow the codes and guidelines, codes and standards. So they defines a lot of criteria which is very, very useful, like ISRE, ASRE, ARI, SMACNA, NBC, NFPA. So ASRE defines for FLACIA requirement and the energy efficiency part of it during equipment selection. SMACNA defines the ducting design, how you can do it. NBC defines the smoke part of it and smoke control system and life safety part of it. NFPA defines how you can do the kitchen ventilation, smoke ventilation, even ventilation, general ventilation. Yeah. So this is the various type of equipment we have available for HVAC system to propose, like depending on the application and the requirement we propose, whether it is air-cooled chillers or water-cooled chillers or DX system. And then, air handling units, there will be floor-mounted air handling units, there will be fan coil units, smaller scale fan coil units, there will be ceiling suspended units, there will be fresh air handling units, there will be precision air conditioners, cabinet type centrifugal fans, air washers for ventilation systems, then axial fan for ventilation systems. So this is the lot of variation in HVAC equipment we can propose. Now coming to space required for HVAC, which is really very interesting, and it is required to be explained to all of the building services engineer, including architects. So it is our duty to explain our requirements so that accordingly building can be designed in a proper way. So as you know, HVAC takes a lot of spaces. Even this is a major space occupier in terms of the ducting, in terms of piping, air handling units, in terms of shaft. So starting from the chiller plant room, if you see the right side plant room is a huge space required for chiller plant room. This is a typical water-cooled chiller plant where chillers, you can see it is placed over here. There's a large main header pipes will be running at the top. Then chilled water pumps will be there, condenser pumps will be there. Then air separator, expansion tanks, all those elements will be there for the plant room. So and at the same time, we have to keep accessible space between the chillers, pumps, and all other equipment for the future maintenance and access. So it's a huge space requirement for the plant room. Similarly, air handling rooms are required for the to distribute the air, cold air to the desired locations. Similarly, precision air conditioning rooms are required for data centers, IT rooms, LV rooms. Fan rooms are required wherever like basement ventilation or any other kitchen ventilation or any other locations. Then shafts, there are a huge shaft requirement for HVAC systems, for seal water pipe, for fresh air ducts, for toilet exhaust ducts, for electrical room ventilation ducts, for staircase pressurization system, for lift well, lift lobby pressurization system, for smoke exhaust systems. And obviously, there's a major and most important part is basically the space between false ceiling and true ceiling, the void space, where normally in any building the services runs and it is camouflaged through the false ceiling. So nice aesthetic feels can be provided by providing the false ceiling. So it is very important to assess the space required between the false ceiling and the true ceiling. So there actually one major part involved is the structural element, which is beams. There will be beams. So we have to see how we can accommodate our system in discussion with structural designers, in discussion with other MEP services, because there is the void space is the only space where all the services runs, including HVAC ducts, pipings, electrical trays, fire pipes, water supply pipes, LV trays, fire protection, fire detectors, everything on top of that. At the same time, we need to have a proper accessible and maintained for that access panels are required for the false ceiling. So it is very important to discuss with architect and structure in collaborative way. We have to sort out the space. Architect obviously always will try to increase the false ceiling height levels, obviously, because it is the main aesthetic part of it. So at the same time, architect's responsibility to check MEP requirement and incorporate in the building. And the structural designer also has to be, in such a way, the design should be there so that optimized space can be provided and get a clear, nice false ceiling height for the space. If I go to a particular typical office floor layout, you can see the space requirement for HVAC system is large air handling units. Rooms are available here. To serve the office building top and bottom. There will be fire towers as per the NVC requirements, depending on the building length, either one fire tower or it has to be 2 fire towers. Now, for this particular building length, it is required 2 fire towers. And there will be requirement of pressurization of those, staircase pressurization as per NBC, lobby, lift lobby, staircase, lift lobby pressurization, lift well pressurization, and then similarly, they will have toilet blocks for the toilet ventilation shaft. So if you see all these, shafts, this red, green, and all this, you can understand the amount of space required for HVAC. So if you discuss at the beginning of this project with the architects and keep provision for all those things at the first place, so we can avoid a lot of problems in the future while we progress in our design. Now, if you see the typical equipment sizes here for water-cooled chillers, definitely it has to be in the plant room. Then air-cooled chiller, it has to be in the outside. Pumps, we have to keep it, either it can be, mostly it is inside. We can keep it outside, but it's obviously it's suggested to keep it inside. Cooling towers, obviously you have to keep it outside. HUs can be inside or outside both. But if it is outside, then you have to see the specification of the HU. Like you have to provide thermal break and all other stuff, so you have to incorporate in the specification. Ceiling suspension and FCUs are, yes, major space occupier, as I said, in the false ceiling void. Similarly, axial fans, cabinet fans, yes, this can be outside and inside as well. Now the accessible and maintainable space required for the major equipments like water cooled chillers. If you see the front, yes, there is a space required of at least equivalent one chiller size, because the chiller coil need to be maintained in a periodic in every maybe periodic phase. You have to clean it so that it performs well. So that to remove that coil, you need some equivalent space. So you have to keep during design of a plant room, you have to keep that space. And between the chillers or after the chillers, we need at least 2.5 meter gap. Then air cooled chillers, we have to have 2.5 meter between the chillers or any obstruction if it is there. Then pumps and then cooling towers, we have to have a space between the cooling towers or any obstruction because of the proper air circulation and the performance of the cooling tower. Air handling units, yes, obviously this is a very, very important part while doing the HV room sizing. So if you do if you do a check of like the requirement of HU room space and the clear space for the HUs, there will be chilled water pipe connection, there will be motor removal, there will be blower removal access space for the air handlers. So accordingly, we have to see what is the coil size, what is the blower, what is the motor size, and which side of this HU we are providing chilled water pipes connection and all those things. So we need a suitable space to remove the equipment from the HU for future maintenance. So that we have to very important to keep it in our mind and incorporate in the design. Similarly, ceiling suspension HU FCO is also required for the filter cleaning at the back and the valve accessible maintenance between the between the equipments or from the wall and the equipments. Okay, now these are some our like right side, if you can see, is a air cooled chillers located at terrace. The space, sufficient space given between the chillers, and there is a sufficient space given here with the handrail of the elevated platform. Sorry. Left hand side, if you see the picture, this is basically we have installed recently in our FIFA World Cup stadium in Qatar. There's a 20,000 plant capacity, so you can ground floor level 0 provided all the chillers, basement all the pumps, and terrace there is a cooling tower. So this arrangement is for the large scale of chiller plant. And then if you see the chilled water piping trench, so this is nicely done. If you see, the nice coordination has been done during the design and it has been implemented. So both sides chilled water pipes are pipes are arranged in such a way, and centrally the accessible space, and all the water pipe lines and the fire pipes, everything has been taken the overhead with the supporting arrangement. If you see the right side, there's a chiller plant with the pump arrangement. You can see the accessible maintenance space available, nice epoxy flooring for the neat and clean chiller plant appearance you can see. So coming to the false ceiling requirement, if you see the top pictures right side, you can see the wide space between the true ceiling and the false ceiling. So what are the systems are like that? There are some pipes, there are some HVAC plenums are there, some ducts are there, chill water pipes will be there, and all of the stuffs will be there. And when you can see the neat and clean false ceiling is there. So wherever there are dampers for the ducts, we have to have access panel. So this is very important to discuss that particular access and maintenance requirement and providing the access panels in the false ceiling. So wherever there are access required, like for fire detectors or for HVAC dampers, we have to have access panel in that. So it is very important. One thing I would like to tell you here, like when you do the space requirement for the wide space, we have to see the same time beam height of that particular space. At the same time, you have to see the false ceiling material. What is the false ceiling overall built up height? Like normally we consider that either it has to be either it will be gypsum false ceiling or metal false ceiling, or is a grid type gypsum false ceiling. So if the gypsum false ceiling, we consider 12 to 20 mm thick of the gypsum false ceiling, but we ignore normally the support behind that gypsum false ceiling. That takes a lot more space. It depends upon the arrangement of the supporting arrangement of the false ceiling, but it takes a lot more space in some of the arrangement. So we have to take into consideration while doing the design that what is the total false ceiling depth is there, so that no service should touch the false ceiling to avoid any vibration in the false ceiling. So now I would like to give our one of our project, one of our airport project, where this is a pier level 0, where all the equipments, you can see the all around there is the external space. So all from departure levels and all other upper levels, all the ducts for kitchen exhaust system, for toilet exhaust system, smoke exhaust, sorry, and the pressurization system, everything we have kept all the fans all around the building. So this much of ventilation ducts are basically running in this particular floor. Even if we incorporate the air conditioning duct on top of that, you can see the right side picture. If you incorporate the chilled water pipe and the ducts, it's kind of like a mess here. So this much of thing, if you have to incorporate over and over, we have to incorporate the cable trays, all other MEP services in it. So it's a huge task to do and get the proper false ceiling height. So while doing this, we have to have a scheme design for this. So we have to check what is the beam height, what is the desired false ceiling height, and how we can accommodate our services. So this is the metal duct for us. We have to size, and it's a large scale project. So definitely the duct sizes are also is a big duct. But one thing I'd like to tell here, while doing the duct design, architects should know one important factor, because normally they propose that you reduce the height as much as possible of the duct and the proposed. But the problem is we cannot reduce the duct height as we want, because there is a method work in it for the ducting design is the aspect ratio. So we cannot go beyond 1.1:4. So if the duct width is if duct height is 1 meter, we cannot go beyond 4 meter of the duct width. Rather, if it is a 4 meter, we cannot go beyond we cannot go beyond 1 meter. So basically it's a to avoid the, basically why you follow the aspect ratio is to avoid the pressure drop and the noise in the duct. So if you go beyond the thing, so it will increase the performance. We'll lose the performance, and then it consumes a lot more power in it. So that is what I would like to tell, that whenever there is this is a challenge for all of us, because we have to have a clear height for the false ceiling. At the same time, we have to incorporate all our requirement. Now, ventilation system is very, very important for any building. Like ventilation in terms of ratio for air conditioning space, which we follow as 62.1. They give the guideline depending upon the application. So this kind of building, if you see a complete facade means glazing facade, where there is no space to accommodate any element apart from this. So within this challenging facade, we have to incorporate the fascia, which we have to take it from outside. Basically, there will be external louvers provided. So external louvers is one part we have to discuss with architect and provide in a suitable locations as per the aesthetic requirement of the building. Now, apart from the air conditioning ventilation part, there is a fascia part. There is a ventilation requirement, which is through mechanical and forced ventilation or natural ventilation. So mechanical and forced ventilation, where it is there, we have to provide fans. Excuse me. Sorry. So natural ventilation, where we can go for is if you have windows or louvers through where the air can come and inside the building, and it can be cross ventilated. If that is not the case, if it is an air conditioning building or it is a complete enclosed building, so we have to go for mechanical ventilation, where we can go for ventilated ventilation fans and all. So bringing outside air is definitely is a challenge. So here, as I said, the forced ventilation can be through mechanical exhaust fans or natural supply air, or mechanical supply and mechanical exhaust. So there are other ventilation requirements for the basement car park, toilet, electrical rooms, plant rooms, pump rooms, STP, WTP, kitchen, stores, etc. Now, since lot more equipment involves in a building to provide HVAC system, it is the most the power consumer for a particular building. This is a typical pie chart of analysis of an airport, where you can see the HVAC is the major stakeholder for the energy consumption, which is 25%. So energy efficiency is very, very important for HVAC. So if you see, first of all, our equipment should be efficient. So whatever equipment you will select, it has to be higher COP level. It has to be all energy efficient equipments. And at the same time, when you do the ducting design and piping design in coordination with architects and structure, we should avoid the more and more bend of the ducts, more and bend of the pipes and all. So we have to avoid all those bends and pipes. So each and every bend has a pressure drop, so which finally it goes to increase the static pressure and increase the power consumption of the system. So that also we have to keep in our mind. Now coming to the smoke control system of the building. So smoke, like today's scenario, when NBC 2016 gives a wonderful guideline for smoke control system, MEP gives the wonderful guideline for smoke control system, and all other buildings now it is a mandatory requirement, because human health is most precious thing for us. So we have to keep smoke-free building, even there is a fire in a building. So people basically smoke control we do to evacuate people from the building and safely evacuate for the people. If you see, there are guidelines as per NBC, NFPA, BS, and local fire norms. So they defines like where we have to give, pressurization system. So NBC gives in table 6, like depending on the building heights, where you can go for pressurization and all those things. There are different techniques of smoke control system, like natural ventilation, staircase pressurization, lifter pressurization, basement smoke ventilation, atrium smoke ventilation, and above ground smoke exhaust system. This is a typical, car park ventilation system layout, where you can see the ducted ventilation system. Basically, I would like to tell you the car park ventilation system can happen through two methods. It's a ducted system. Another is a ductless system through jet fans. So this is a ducted system where you can see there are fan rooms here and there are fan rooms here. So exhaust and supply fan rooms are there. There will be shafts so that it can go out and take the fresh air in. and the ducts will be running all across these car park areas. And through there will be CO sensors provided in the different locations based on the CO level of that particular car park zone. The fan will be operated. In as per NBC, it is given that 6 air changes per hour we can go for normal ventilation, and 12 air changes per hour for the smoke ventilation. Now coming to the ductless system where the jet fan. So this is the system wise, it is both same. There will be fan rooms and air distribution. Instead of the duct, there will be jet fans provided. So one jet fans will direct the smoke towards the another. If any smoke happens in this particular zone, so jet fans will actuated and it will start running at its full speed, and it will direct the smoke towards the exhaust fan. So this is the basically difference between the ducted and non-ducted system of the basement ventilation. So it is very important to provide the system where you have a larger height of the basement, because you have to maintain minimum 2.4 meter height in the basement. So depending upon the height, available height of the basement, we can propose ductless or ducted system. This is some actual photographs of our executed project. It is one of our Ford IT park in Chennai. You can see the ducted system implemented over here. This is the ductless system ventilation fan is indicated here. Okay, the left hand side, whatever you can see, this is a basically makeup air lower, which is a courtyard between the buildings where basement is at the below. So the makeup air is arranged in such a way that it is a part of now landscape. It is created, and all around the louvers are arranged in such a way that it's nicely incorporated or integrated with the landscape part of it. So architect plays a wonderful role in this. So they can propose nice, wonderful ideas where we can implement our things and perform well. Right side, you can see some basement ventilation fans. This is basically a staircase pressurization system where you can see there will be staircase, means there will be adjacent, there will be one shaft required. So vertically you can see there is a shaft required, and from that shaft particularly each the staircases, all these grills are provided to pressurize the staircase during fire. And lift well, lift lobby pressurization, you can see as per NBC, if you have continuous lobby for all the levels of the lifts, then you may not require to pressurize the lift wells. You can have pressurization for the lobbies alone. But if you have any floor, if you have a discontinued lobby, you have to pressurize the lift wells. So we have to provide lift lobby pressurization shaft we have to incorporate, and there will be multiple ducts in each floor with a motorized fire damper, so that whenever there is a fire, the fan can actuate and it can pressurize the building. So basically what we do in our selection of fan sizing, like we check the pressurized required for any particular floor in the above floor, and below floor, whichever is higher, we can take it. We can take the CFM or air quantity, and then we check ground floor what is the pressurization air requirement. So we sum up those, like the maximum of above ground and below ground, and then we add the ground floor requirement and we size the fan. So whenever there is a fire, so basically the ground floor and the affected floor duct will be, the damper will be open and the pressurization will be done. Now there is some physical appearance of the fan arrangement and the shaft connection with the shaft. The fans with the duct, it is connected to the shaft and pressurizing the staircases. This is NBC defines this 2016 very nicely explained how we can do the atrium smoke exhaust system for any building. Either it can be a mall or it can be a larger lobby in entry lobbies in big IT parks or office buildings. So how we can do it, and what are the total air changes, 6 to 8 air changes we can consider. So it's a nice guideline they have given in Annexure F. Coming to the CFD simulation system, like if you go for this is one of our airport projects, which is Hyderabad Airport project, where we have a big volume. Normally in airports, we'll have a big volume of spaces like check-in halls. We have departure hall, we have arrival halls, where we have to provide smoke ventilation system through smoke roof extractor at the roof and make up air through the glazing windows. So there is a nice coordination is required with the architect, like where we need the openable windows to perform the smoke exhaust system. So all those, if you see right side, there are some windows locations are indicated. Those windows we have to give the requirement at the beginning of this project, so that they can architect can incorporate in the building. So while doing this estimation, there are very important aspect is basically we have to see what is the window area required, free area required. If it is a roof extractor through extract and make up air through windows, then what we do is 2.5 meters per second velocity we consider for the make up air window, and we size the window requirement. And then we can check if it is a motorized window, it cannot be a full openable window. It has to be with a certain angle it will open. So we'll not get the effective full area opening. So we have to go for a larger number of openable window in that case. So if you see the smoke exhaust system, this is the typical schematics of that. Roof extractors are there, and side you can see openable windows are there for the makeup air. And then we do the heat load, we do the CFD analysis for the smoke ventilation, and we define basically fire source location, and then do the analysis. If you see the next slide, it can show the 20 minutes plot. We do basically 7 minutes, 10 minutes, then 20 minutes, and so on. We can see, and we can check the visibility level. Basically, a smoke control system is required, or smoke exhaust system is required to provide the visibility inside the space. So we draw a line of 2 meter space where occupied zone is there, and people can evacuate. You can towards the exit. So here, if you see, the fire source is here, and it is the smokes are generated, and the once this is there, through fire alarm, and the fan will be actuated, and it will be directed towards the the fan, so that the smoke can evacuate. Smoke always travel through vertical, and it touches the first, it will touch the ceiling, and then it will horizontal, it can spread, and it will getting down slowly. So the moment it fire alarm actuation is happened, and then immediately the smoke exhaust can start, and we can get the visibility part of it, and people can evacuate from the building. There are some pictures for ventilation system. This is the kitchen ventilation system. So kitchen ventilation system, these are the burners and all, and this is the cooking area, and this is the hoods provided for the exhaust system. So there at the top of that, the duct will be connected, and it will be exhausted outside. There are some ducting arrangements, so sheet metal ducts over here, some rectangular ducts, some circular ducts, and these are some fittings of the duct. There is some piping arrangement at the back, the left side, and the right side valves arrangement you can see. And this is basically interior aesthetic requirement by the architect. So all this is basically a baggage reclaim area where this like air conditioning towers are there. You can say binnacles also. So there will be air conditioning outlets, whether it is a jet nozzle or it will be drum louvers at the top for the air conditioning. See here, it basically is the pier. So nice ceiling with the you cannot see here the grills at the top. So between each and every inclined ceiling, there will be grills provided for the cooling arrangement. So it's nicely incorporated in the design. The MEP requirements by the architects is really appreciable. And this is basically check-in counter where you can see the nozzles are swing here, so to cool that. And similarly, there are some towers are there where at the top binnacles are there, the drum louvers are there. To provide the air conditioning. This is also aesthetic appearance. These are the towers in between where it is through this it is cooling the entire area. Yeah, that's all from my end. If you have any doubt or any questions, please ask me, or you can put it in the chat box. That's all. Thank you.
Thank you very much, Mr. Satyanath Mukuti. I hope you all like this amazing presentation. So if you have any questions, please unmute and ask.
Good afternoon, sir.
Yeah, good afternoon.
Sir, can you provide openable windows and fire staircase, or we have to open it thoroughly?
No, these are openable window means these are all motorized openable windows. So this will be integrated with the fire alarm system. So whenever there is a fire, so fan will be actuated at the same time. This motor openable windows also will be actuated, so that it will open automatically.
Like AOV, automatic operator ventilator.
Yes. Anything, anybody? If you have anything, you can put in the chat box. We can
If the
discuss
staircase
later
is
also.
provided for natural ventilation only, then also
Sorry,
we have to.
Sorry, I could not hear you. Can you please?
If our fire staircase is naturally ventilated.
Fire staircases?
Naturally ventilated below
Yeah,
30 meter height. Business
yes.
building. So we have to open the we have to provide an opening, or we can provide the AOVs also in the windows. Like
You can provide opening, or second, lastly, what you said?
operated ventilator.
Okay, if it is a naturally ventilated staircases as per NBC below 30 meter height building, you know, below 30 meter means there is a criteria between 15 meter to 30 meter. You, even if you are providing a natural ventilation, you have to have a cross ventilation system, either in the opposite walls or it is adjacent walls.
No, sir,
So
it also says natural, like natural or cross both.
yeah, I'm saying
Above
natural
30
ventilation only.
Yes,
In case of natural ventilation, you can have a lower arrangement or you can have a window arrangement, which is not required any automatic system. It will be always keep it open. So you can provide a lowers in adjacent walls or opposite walls to have a cross ventilation. This is required for 15 meter to 30 meter building.
Yes, sir. Yes.
Yeah.
Okay,
So
thank
it
you,
is
sir.
not required to be automated system. It can be fixed one time.
Okay, sir. Thank you.
Okay, thank you. Anybody else?
Okay. Okay, thank you again, Mr. Satyanath Mukuti, for answering the questions and for the guest presentation. It was a pleasure
Thank
to
you.
have you with us.